natural element. There is only a certain example of natural elements. Most of the mineral exist in natural compound. So this is what we learn after this, natural element versus natural compound. But first, I want to look at the meaning of the minerals in the earth crust. So mineral is any element or compound that exists naturally inside the earth crust. So Ryan just asked just now about the natural. So the natural one we call it as a mineral. But when you do something, when you try to extract or you put something, you combine or you try to extract, this is not known as a mineral anymore. So dia just jadi bahan kimia saja. But for the naturally occur inside the earth crust, you call it as a mineral. So they are inorganic solid which has the fixed composition. So fixed composition means that if that kind of mineral contain of one atom, so dia just atom tu saja. Kalau dia ada dua atom, it just compose of that two atoms only. So they are not change. Dia tak akan berubah. So it just fits into what their position are. I mean the compositions are okay. Alright. If you see in the pie chart over here, 47% of the mineral exists as the nitrogen oxygen form. It means that some of the element combine with the oxygen to form another mineral. For example, like iron. Iron is not a mineral, but iron oxide is a mineral. Means that naturally iron exists as iron oxide, okay, besi oksida. When they get the iron oxide, they will try to extract the iron from the iron oxide. That is how you get the pure iron. But naturally, iron occur as a iron oxide. So that's why they put it 47% oxygen over here. So banyak lah. And then iron yang naturally only 4.5% sahaja. And then 28% you have silicon. Silicon mostly composed from the sand, material yang dibuat pada pasir, like glass or something like that. But silicon mostly they refer to the sand. Okay, and then they have others also. Okay, but this one is not very important. So you just need to know the meaning of mineral. And the next part is the characteristic of the mineral. Okay, so how we want to classify the mineral? There is a lot of mineral in the earth crust. So the scientists or the geologists who geologist is the bidang who study about the stone, okay, about the geography, right? Saya best belajar juga pasal batu-batuan. So for the geologist, how they want to classify all this type of mineral, they look at the chemical composition, they look at the arrangement of the atom. So chemical composition means what are the elements that made up the mineral. And then the arrangement of atom, how the atom is arranged, whether it is a uniform or just randomly. So you look at after this. Okay, and then they look at also the physical characteristic, and they look at the chemical characteristic. So physical characteristic is the outer surface, permukaan luar. What can they observe from the mineral? So they can look at from the strength. Is it very strong or just smooth, lembut saja? Okay. So next about the colors. Some of the mineral got different colors, like bauxite. Bauxite they have a reddish color. Iron they have a little bit like grayish color, something like that. Okay, and then the condition of the surface. Okay, try to touch the surface. Okay, you will feel some of them very smooth, some of them is rough. Okay, then some of them are shining, some of them they are dull. Okay, and that's the solubility. Okay, try to put the minerals inside the water or any other solvent. Look at they can dissolve it or not. So they study about that, and then they look at what are the characteristics in order to classify those. They also look at the chemical characteristic. First about the acid or alkali of the compound. For example, you know that limestone. Limestone we use we put the limestone to the soil to increase the acidity of the soil. It means that the limestone is uh, alkali. So this is uh, one of the example of the pH of the mineral. So mineral mostly they have their different pH, but mostly they are neutral. But some a little bit acid, some a little bit alkali. Another one is the effect of heat. Okay, if you introduce fire, if you introduce heat to the mineral, some of the mineral can melt, some of the mineral can form another substance. They can react, and then they will combine with another substance to form a new substance. So this is the effect of the heat. So effect of the heat usually related to the chemical characteristic. Okay? So this is just the characteristic that the scientists or geologists use to classify the mineral. Okay, but for your level, you need to know what is the list for physical characteristic, what is the list for the chemical characteristic. Okay. Okay, this one is very interesting. This is what Ryan asked just now. Okay, naturally, how the mineral was found. Some they can be found as a natural element. Some can be found as a natural compound. So when they are found as a natural element, inside those there is only one element only. But for compound, actually it's a combination of a different element, a few elements. Okay, when they combine it, element combine chemically, secara kimia, it will form a new compound. So you dapatlah ni a natural compound. Okay. For natural element, they are not reactive. Means that if you introduce water, if you introduce another substance such as acid or oxygen, they cannot react easily. But for natural compound, they react easily, and then they will try to form another substance. So this is the difference between element and compound. So it's the same thing as you learn in Form 1. Okay, for natural element, only a few numbers can be found. Okay, not all mineral exist in natural element. There is not a large of number. There is only a few you can find. For example, like aurum, gold. So this is aurum, gold. So you can find gold as it is because gold is only composed of one kind of element which is the aurum. And then silver here, one element also, just argentum. Platinum here, just one element also, is the platinum. Okay, aurum, gold ni, silver and platinum, mostly they use as a ornamental, barang-barang perhiasan. Okay, and then this one is the mercury. Mercury is the only liquid metal that has been found. So mercury also, inside the mercury, there is only one element. We call it as a Hg, hydragyros. Okay, mercury element only. Okay, one. Okay, and then last one is the carbon. So carbon, for example, like the end of your pencil tips, the black color, that one is the carbon. So it exists in natural element. So because inside that one is only one element called carbon. Okay, and then this one you can see here, a diamond here. Diamond is only made up of carbon, but diamond is only made up when the carbon is introduced into high temperature and high pressure. So kalau nak cari diamond ni memang orang cari kat bahagian bawah-bawah kerak bumi because it is hard to find. Okay, because it needs high pressure and high temperature in order to form the diamond. Okay, but inside the diamond there is only one type of element which is carbon. So that's why diamond, gold, silver, platinum and mercury is categorized under natural element. Okay, alright, for natural compound it exists because a few elements combine. Okay, and then most of the mineral exist as compound. So kebanyakannya mineral yang kita jumpa dekat dalam tanah kat bumi ni adalah secara sebatian semula jadi. It's a natural compound. So there are a lot of examples, and we will look at after this one by one. But here are some of the examples. So this is bauxite. Okay, bauxite is aluminium oxide. So galena is plumbum oxida. Okay, this one is the limestone, batu kapur. Okay, and the last one is hematite. Hematite is the iron oxide. So we will look after this for the natural compound here, and then what are the uses of those minerals. Okay, for the natural element, it's only a few examples, and then I already explained about the use. But for the natural compound, we will look at one by one because this one is a little bit difficult because it's a lot. So the first one we will look at is the natural compound that in their name got oxide. Okay, so oxides means that one of the elements exists inside this natural compound contain oxygen. Okay, so that's why they call it as the oxide. For example, here is the hematite. So hematite, the scientific name for hematite is actually iron oxide. So if you look at the name of the scientific name here, you can see iron and oxide. So it means that elements present inside the hematite is iron and oxygen. Okay, and then this hematite, they mine it, dia lombong untuk dapatkan besi tulen. So they mine all the hematite, all the iron oxide here, and then after you got it, you take this hematite, you extract in order to get the pure iron. So this iron you can use to make the iron products such as nail, then you have a fans, something like that for the iron. Okay, so that they get the iron from the hematite. Okay, the second one is cassiterite. So cassiterite, okay, you guys need to remember the mineral name, okay? The common mineral name, the scientific name, and the elements present inside the mineral. So for cassiterite, the scientific name is the tin oxide. Okay, timah oxida, the tin oxide. So it means that inside the cassiterite, you will have you will have tin, and you also have the oxygen. Oxide means oxygen. You got tin and oxygen elements present inside the cassiterite. Okay, why they want to get the cassiterite? Because they want to get the pure tin. So timah tulen. So biji timah, so you guys learn in geography, Cikgu Mustaqim ajar kan, yang lumbungan biji timah. Banyaknya dekat Perak tu lah. So they get the biji timah, they get the cassiterite in order to get the pure tin. Dapatkan timah tulen. So timah tulen, they can use to make such as like ornamental products. Okay, if you know Royal Selangor, if you go to the Straight Key, yang mall tu dalam tu, they have one shop known as Royal Selangor. So Royal Selangor, they usually sell all the kind of product or souvenir or ornamental made up from the tin. So it's a little bit expensive than the iron because iron you easily get. So the price is quite low. But tin nowadays is hard to get the tin. So because of that, the price for the tin becomes higher. Okay. Okay, the next one is also common, bauxite. Okay, bauxite actually made up of aluminium and oxygen. So that's why the scientific name is aluminium oxide. Okay, so they get the bauxite in order to get the aluminium. So aluminium can be used to make aluminium foil, and then the tin, air tin yang you minum tu, because the container is made out of from aluminium. So this is one of the examples for the use of aluminium. So how they get the aluminium? Actually, they extract it from the bauxite. So if you remember last year, there's a case in Malaysia because of the bauxite mining, gelombongan bauxite secara tidak terurus. Okay, and it makes the jalan raya, all the roads and sea becomes very red. So because the bauxite exists inside a soil in a reddish color. So, masa dia lombong bauksit ni dia bawa sekali dengan tanah-tanah tu, tapi dia tak menguruskan secara bagus dan mencemarkan alam sekitar. Dia menyebabkan jalan-jalan semua menjadi merah, sungai-sungai jadi merah dan masuk ke laut, laut pun jadi merah. So this is what happened at Pahang last year. Okay, maybe nowadays also there is still some of the effect because of this irresponsible mining of bauxite. Okay. Okay, the next one still under oxide. Okay, the next one is quite special because all the scientific names is the same. All are silicon dioxide. So nama scientific dia semua silicon dioxide. But the mineral exists in a different form. Some exist as a sand, quartz, mica, and asbestos. But they are all the same in terms of the scientific name and the elements present, because the elements that made up these minerals are the same, which are silicon and oxygen. But under natural condition, it exists in different form of minerals. Okay, sand, pasir ni, they used to make a glass or ceramics. Okay, quartz, they make the radio, watch, TV screen, electronic chip. So if you notice some of the watch brand, the company ada yang nama quartz kan for the watch, because they made the glass of the watch from the quartz mineral. Okay, this one is mica. Mica is also very famous nowadays because they use as a electrical insulator. So if you notice the wiring, the outside of the wire, you need to coat it with one substance, right? So this is, you can use like PVC, mica, or asbestos. Okay, asbestos also they use as a wiring insulator. Okay, they are the same. Because the mica and asbestos is a very good heat insulator. So it will not allow the electric to be conducted, and then you will not get the menjatan electric shock when you touch the wire. Okay. Alright, that one is for oxide. Now we go to the carbonate. Carbonate means that minerals that contain carbon and oxygen is inside the natural compound. So dalam mineral tu dia ada carbon dan oxygen. So that one kita akan panggil sebagai carbonate. You can call it as a carbonate. So there are two examples here. One is limestone, batu kapur. So limestone, the name, scientific name is the calcium carbonate. So kita panggil dia calcium carbonate because the elements present inside those are calcium, carbon, and oxygen. And this one you can use to make marmar. Marmar is a jubin or tiles on the floor of your home. Kan ada lantai rumah kan. This one mostly they made up from marmar. Okay, if you notice, you use the plus highway. Okay, kat Perak ada yang bukit yang diorang tara-tara yang diorang nombong. So you can see the hills. Inside the hill there is like a white color or grayish color rocks. That one is the limestone. Right? So another usage of the limestone is they want to extract the iron. They need to put limestone inside the process in order to help the iron to be extracted. Okay. Okay, this one is the malachite. Okay, malachite, the scientific name is copper carbonate. So they put copper inside this carbonate so that you will get the malachite. So you have copper, carbon, and oxygen. So malachite they use usually to make the beads, the like blue green color beads. That one, right? So that one is actually the malachite, made ornamental jade, because they have a very bright blue greenish color, bluish green color. Okay. Okay, the next natural compounds is sulfide. So, so if you see any natural compound that has the name of sulfide means that inside those compound you have sulfur. So for example here like pyrite and galena. So pyrite, the other name is iron sulfide. So the elements present inside the pyrite is iron and sulfur. So they use the pyrite to make to get the sulfur and sulfuric acid because this pyrite contain a lot of sulfur inside those. Okay, usually pyrite can be found in the volcanic area because volcanic area contain high amount of sulfur. So the next one is galena. Okay, galena, the name is the lead sulfur. Okay, ada plumbum dan sulfur kat dalam dia. Got lead and sulfur as well. They mine the galena in order to get the pure lead. Okay, alright. The next one, silicate. Silicate. Okay, such any compounds that contain silicon and oxygen, okay, as the elements inside the compound. So this is the two most famous. The first one is kaolin ataupun tanah liat putih. So inside the kaolin, you will have aluminium. So that's why the scientific name is aluminium silicate. So the elements present are aluminium, silicon, and oxygen. So they usually made up ceramic. Okay, if you notice the tembika yang dia buat tembika yang guna tanah liat that one kan, so they were made up from the kaolin. Okay, to make the ceramic. Okay, and then the next one is the calcil. Okay, calcil. From the name, you know that got cal. Cal means calcium, sil means silicate. So that's why the scientific name is known as the calcium silicate. So the elements present are calcium, silicon, and oxygen. So very easy. Calcium, silicate, silicon, oxygen. And then the calcil is used as a part of the cement. So if you notice, we have two different color of cement. One is white, another one is gray. The white cement contain a lot of calcil. Actually, calcil help the cement in order to be hardened faster. Okay, this one, the calcil, you see this one is a raw material. It is like a rock, but they will process it until it become like a powder so that they can make a cement. Okay, so there are a lot of natural compounds actually. So there is a continuous list actually, but for PT3, for our level, you just need to remember about the oxide, carbonate, sulfide, and silicate, and then you need to know the examples of the mineral. You need to know about the scientific name so that it's easier for you to remember what are the elements present inside the mineral. And then you need to know a little bit about the use. Okay, mostly this topic will come out in section A or B of the exams. Not C, jarang lah. So A and B only. So this one is a lot of facts, okay, but not a lot of kebat or hot. This is just a lot of facts that you need to remember. Okay, that's all about 4.1, the variety of minerals. Okay, if you have any question about 4.1, you can ask. Okay, type your question on the chat area. So if you don't have any question, I will move to the 4.2. This one is more interesting about the metal. Only focus on the metal. So we will continue with the metal reactivity series.
Cikgu,
Yes, Raif.
yang apa yang semua ni kena hafal ke? Potassium, sodium daripada urutan.
Yes. Okay, the metal reactivity series, you need to remember their position. Siapa yang paling atas, siapa yang paling bawah. Okay. Apa maksud dia sebenarnya? Okay, metal reactivity series actually is an arrangement list of metal reactivity from the most reactive to the least reactive. So at the top layer is the most reactive, and then at the bottom layer is the less reactive. Means that the upper part they easily react with another substance. So if you put water, if you put oxygen, if you put acid, they will react, and then you can see the reaction by the production of flame, production of air bubble, something like that. But for the bottom part, if you put anything, they will not react. Means that there is no difference. There is no observable reaction that you can see if you try to mix these metals with another substance. So kalau you nampak dia bertindak balas, dia reaktif. Kalau dia tak bertindak balas, dia kurang reaktif. So macam mana how the scientists come up with the reactivity series, we'll look at after this. Macam mana dia dapat tahu the potassium is the highest and the gold is the lowest. So they do some of the experiment in order to prove this. Okay, but before that, you need to remember the list. Okay, okay, the first one we look at the K. K means potassium because K is kalium. So second, sodium Na, natrium, calcium Ca, magnesium Mg, is the symbol. Aluminium Al, zinc Zn, ferrum Fe, tin Sn. Sn means actually the scientific name is stannum. The common name is tin. So that's why they use Sn over here. Okay, lead, Pb means plumbum. Copper, they use Cu. Mercury, the scientific name is actually Hydragyrus. So that's why they use Hg. Before this, they use Hydragyrus, the name. But they changed into the Mercury. And then silver, they use Ag. Ag means argentum. Okay, means silver, perak. And then and last one is the gold, aurum. Okay, aurum, A-U-R-U-M means gold. Okay, gold. Okay, ada list yang baru dia letak bawah gold dia put platinum, PT for platinum. So kalau you guys perasan, dulu-dulu lah gigi orang yang dah cabut dia buang, digantikan dengan gigi emas. They replace with the gold teeth. Why this replacement they made up from the gold, not from the iron or anything above than metal yang kat atas ni. Kenapa tak guna yang atas ni, dia guna gold. They use gold because the gold is the least reactive. So when the acid inside the mouth or water inside the mouth react with the gold, it doesn't produce anything because gold is the least reactive. It doesn't react with the water, acid or anything else. But if you put iron, besi, iron will rust. So dia akan bertindak balas, dia akan berkarat. So that's why it's not good to use iron. So they use gold. But nowadays, they don't use anymore the gold anymore. They use somehow like plastic version yang lagi hebat lah. Some also use platinum. But mostly now they replace with the fiber plastic. Yes, safer. Okay. Alright. Okay, this is the example on how you want to remember. You can use the mnemonics. You can create by yourself or you can take this example. But for this one, maybe they don't put the complete list. The complete list is like this, the different slide, the first slide over here. Okay, this is just the example, the mnemonics and how you want to remember it. So it depends on you. You can make up by yourself. It is better because you made it, so it's easy for you to remember. So if you don't want to make a new one, you can uh, Google or take from here. So for example, like this, you can take the first letter and then you change the next letter to make a story. So for example, this one, please stop calling me a careless zebra. Instead, try learning how copper save gold. So adalah macam-macam cara nak ingatnya. Okay, jadi please P kan, P potassium, S stop for sodium, calling C for calcium. So you can make up what by yourself is good for you because it's easier for you to remember. If I remember before this, Raif dah buat satu list masa kelas yang sebelum ni kan. So Raif, you guys boleh share dengan kawan-kawan you apa yang you buat. So depends lah, the story depends on you. Okay, alright. Okay, this is the example of how scientists they arrange the metal according to the reactivity. So before this, they don't know which metal is reactive, which metal is not reactive. So so they do some of the experiment in order to determine their position. So one of the example of the experiment they use water. So this is the video. Okay, if you look at this slide, you can see the red one is the metal, the green one is the metalloid or half metal, and then the blue one is the non-metal. Okay, there's a lot of metals exist in the earth, so that's why you can see a lot of metal in the periodic table. So for this experiment, they select a few metals. So okay, what they select is a zinc, and they put inside the water. They put zinc, copper, potassium, calcium, ferrum, lithium, magnesium, and sodium. So if I repeat the slide again, you can see so far they put zinc, nothing happened. Put copper, nothing. Put lithium, got flame. Calcium, a little bit of bubbles. Lithium, explosive. Sodium also explosive. You can see the explosion a little bit. Magnesium, it produce a little bit of bubbles. So the record, what is the observation from the experiment? For example, zinc, copper, iron, there is no sign of reaction at all. But for potassium, you get instant violet reaction, violet flame, just a bit of flame. And then water, when you touch it, it's a bit hot. Okay, and then the reaction happen faster, instant, berlaku dengan segera. Calcium is a quick reaction but not instant, and then they release some of the hydrogen gas, but there is no flame. Lithium, very rapid reaction. There is hydrogen, and then the water is a little bit hot. Magnesium, very slow, but you can see little bit of bubbles. And then the sodium is an instant reaction. You can see the flame a little bit. And then there is a hydrogen, air bubbles, and the water is hot. So based on the observation, they rank it according to the reaction, which one is reactive, which one is not reactive. So they come out with the result. Potassium is very reactive, followed by sodium, lithium, calcium, and magnesium. But somehow iron, copper, and zinc, they don't know the position because they doesn't show any reaction towards the water. So they think another experiment, okay, they replace the water with the dilute hydrochloric acid, okay, because acid is more reactive than the water. So perhaps zinc, copper, and ferrum can show some of the uh, reactivity. They can you can observe something from the reaction. So they do the reaction and then they come out with the list. You can see the magnesium, there is a rapid reaction, a lot of hydrogen air bubbles. And then the acid will up the plug, the tube. You can notice that the temperature is a bit higher. Zinc is a slow, steady reaction to make hydrogen. Ada got air bubbles, but a few. Ferrum slower, and then copper there is no reaction at all. So you can rank it 5, 6, 7, 8. And then you combine with the previous experiment. Okay, yang water and hydrochloric acid you combine together, and then you run them, and then you get the metal reactivity series. But that one is only a few kind of metals. Okay, but if you want to do all the experiment, you can use all the metals, okay, from potassium until the platinum. So this is how they come out with the this is the experiment how they come out with the metal reactivity series. Okay, and then for the next part, okay, lithium, sodium, and sorry, okay, for the lithium, sodium, and potassium, you can notice that they are very reactive just now. So you cannot leave it to the surroundings just like that. So you need to cover them with something else. So in this one, they put oil inside the, means that you put the metal inside the oil. Okay, and then you keep them from any moisture because they are easily react with the water and oxygen. So they will form a very big explosive. So if you don't put it inside the oil, so they are very dangerous. So um, it is quite dangerous to do the experiment actually. Okay, so they put it inside the paraffin oil. Okay, all right. Okay, this one is the chemical formula, but you guys tak perlu belajar ni lagi. Just show the example uh, macam mana potassium tu akan tidak berlainan dengan hydrochloric acid, dia akan produce apa. But this one, you guys can learn in chemistry if you take chemistry in form 4, form 5 lah. But this one you just need to know about the metal reactivity series and how they react with water. Siapa yang kuat, siapa yang lemah. Okay, alright. The next one is the oxygen. Other than water, the scientists also try to do the experiment with oxygen. So oxygen will react with the metal. They will form a flame. Dia akan terbakar. So kekuatan dia terbakar tu, the flame, whether it's very big or very what we call it, just a little flame. We will see. We will observe that, and then we can rank the metal reactivity series based on the flame produced. So for this experiment, they use a certain metal. Okay, you cannot use lithium, sodium, and potassium because they are very explosive and very dangerous. And then you need to try a little bit lower like calcium and also magnesium. So for this experiment, they use magnesium. Okay, they take the magnesium and then they introduce some of the fire and oxygen, and you can see a very bright flame. It means that magnesium is a very reactive metal, so that's why it produces a bright flame. It glows very brightly. Okay, what you get after the magnesium is burning with the oxygen, you will get the magnesium oxide. Okay, they try to do another experiment. They use copper. Okay, if you notice, when they burn the copper just produce or burns only brightly. Doesn't produce any big flame, just a little flame only. So it means that magnesium is reactive than the copper. Okay, last one they use iron. So iron, you can see the sparks because iron is above the copper, so it will produce the spark, but it doesn't produce any what we call it the bright flame. So it means that from the experiment, magnesium is on top, iron in the middle, and copper is at the bottom. Okay, so this one you actually we can try to do the experiment with another kind of metal such as titanium, aluminium, gold, plumber, zinc. Okay, but for the calcium, potassium, or sodium, it's very dangerous to do this kind of the experiment. So actually, the scientists they come up with the chemists lah. They come up with a lot of experiment, water, acid, oxygen before they come out with the metal reactivity series. So this is how they come up with the metal reactivity series. Okay, all right. So any question about the metal reactivity series?
Teacher,
Yes, Ryan.
ada macam nak kata macam ada tak macam susunan lain tapi pasal macam tekstur ke dia punya liquidity ke memang ada reaktif je?
Okay, untuk metal reactivity series is according to the chemical aspect lah. Dia punya sifat-sifat kimia dia. So untuk sifat kimia, dia bertindak balas terhadap asid alkali dan tidak balas terhadap dia punya kereaktifan ataupun haba logam dia. So, sebab itulah siri kereaktifan dia bergantung kepada reaktif ataupun tak reaktif. So untuk ciri fizikal, they don't have the list because tak ada yang panggil apa macam sangat kasar, sangat lembut. Itu memang ada sangat kasar, sangat lembut macam tu. Tapi for the list yang betul-betul proper, tak adalah untuk ciri fizikal. But for the this one, untuk reactivity ada. Untuk reactivity, it depends how they react with another substance. But for physical, it just only them. Dia tak react dengan siapa-siapa. Hanya diri dia sendiri. Okay, alright. Okay, Ryan, teacher, how is it possible for the scientists to identify the elements in the metal? Okay, how they identify the elements in the metal? So, um, the first one, actually, okay, for the compound, they extract and then they get the elements. Alright, and after that, the element that they know, they see from the previous one based on the characteristic lah, based on the physical characteristic, chemical characteristic, based on the uh, chemical composition. So this is how they cannot look inside. Okay, they just can look the outside. Okay, for the new one that they don't know, they will come up with the new name. But we already 2020. Before this, 100 years, 1,000 years before this, scientists already, chemists already find the metals. And then they already name it. So they just compare to the one that they find it before this. Okay, any other question? Ada soalan yang lain?